Look, I know how this sounds, but you gotta understand, it's massive in there.
I'm not saying I don't believe you.
Okay, I'm gonna come back here with proof.
It all starts with the most harmless thing imaginable. A photograph of an empty office room taken around 2003 in the back of a hobby shop in Wisconsin. Yellowish wallpapers, fluorescent tubes humming on the ceiling, a doorway opening onto another room that looks exactly the same. In 2019, an anonymous user on 4chan turned it into a legend. If you ever clip through reality in the wrong place, you fall here. Into 600 million square miles of empty rooms. The internet called it the Backrooms, and A24 has now turned it into a film. But what's truly frightening about this place isn't any of the entities lurking in it. It's a mathematical idea. Around 300 BC, a Greek mathematician called Euclid gathered all the geometry of antiquity into one book, The Elements, and deduced everything from a handful of postulates taken as self-evident truths. It's the geometry we all learn at school. A straight line is the shortest path between 2 points. The angles of a triangle add up to 180 degrees, and parallel lines never meet. For more than 2,000 years, this was simply how space worked. No alternative seemed possible. Then, in the 19th century, mathematicians like Gauss, Lobachevsky, and Bolyai discovered perfectly consistent worlds where the rules bend. That's what non-Euclidean geometry means. On a curved surface like a sphere, parallel lines end up crossing, and triangles grow fat past 180 degrees. On a saddle-shaped surface, they slim down. Horror writers fell in love with that idea. Lovecraft built a whole cosmic dread on it. The sunken city of Raleigh, with its impossible angles where acute behaves like obtuse, or the dreams in the witch house, where the strange geometry of an attic room becomes a doorway to other dimensions. Ever since, non-Euclidean has been the standard label for any space that feels wrong. It sounds great, but for the Backrooms, it misses the point. Look closely at those yellow rooms. Nothing curves at all. The floors are flat, the walls meet at perfect right angles, and the curvature at every single point is zero. Locally, the geometry is flawless, boringly normal. What breaks is something subtler. The problem isn't inside each room, it's in how the rooms are glued together, and that's exactly what topology studies. Forget distances and angles. Topology looks at the properties of a space that survives stretching, bending, and deforming it as if it were made of rubber. What it cares about is connection. How many pieces a space has, how many holes, which paths loop back on themselves. To a topologist, a coffee cup and a donut are the same object because one can be molded into the other without cutting. So when the rooms of the Backrooms are glued together in an inconsistent way, you can walk in a straight line, feeling nothing strange under your feet, and end up at coordinates that shouldn't exist. The only thing that still matters is connectivity, whether two walls are truly attached or whether that corridor quietly returns you to the entrance. To see it clearly, mathematicians strip a maze down to its essence: dots and lines, junctions and corridors. A well-built maze is what they call a tree, a network of paths with no closed loops, where every new corridor reveals a new room, and you can never close a circle without cheating. That's why the oldest trick in the book works. Put your hand on the wall, never lift it, and walk. Since the wall is one single connected piece with no loops, following it will lead you, sooner or later, to the exit. Walls and paths are two sides of the same coin, what mathematicians call duality. If the paths form a tree, the walls form another tree, woven through the same space. So, how many mazes are there? In a simple grid of 10 by 10 rooms, the count reaches a number with 43 digits. Make it 15 by 15, and you pass 10 to the power of 100. More possible mazes than there are atoms in the known universe. The horror of the Backrooms is that they break the tree and flood the space with loops. There's a number that measures exactly that, how many independent loops a space contains, the first Betti number. In a tidy maze, it equals 0. Here, it shoots off to infinity. And then the hand on the wall trick betrays you. You can spend an eternity walking in circles, in silence, inside the same loop. The unsettling part is that this fear is old. In 1941, Borges imagined the Library of Babel, endless identical hexagonal galleries, a sphere whose center is any hexagon and whose circumference is out of reach. Without knowing it, he was describing a compact manifold without boundary, a space like the surface of the Earth, where you can always keep walking and never hit an edge. Decades later, the Argentine film Möbius took the same idea into the Buenos Aires subway. With a network so overconnected, it twisted into a Möbius strip and swallowed a train whole. The internet has simply swapped the wood and concrete of those old stories for the synthetic yellow of some forgotten office. The mathematics of the nightmare hasn't changed in centuries. Only the carpet has. Liked it? A thumbs up and a subscribe help more than you'd think. This one's a bit of an experiment for us, so let us know if it works. Until the next one, see you.